Okay, guys, in this lesson, we are going to talk about some of the properties of logarithms that are not the basic ones that we did in our last one. So, back in 3.4, we learned all the basics about logarithms and some of those basic properties. However, now we're going to talk about some other properties that you can do when there's maybe operations that are happening. So, instead of just doing like a logarithm of a number, you might end up seeing like a product or a quotient or a power. And in those cases, we have these properties. Now, again, these are things that you probably covered back in Algebra 2. However, it's probably been a while, so make sure that you get your notes written down. And when you are ready for us to move on, then start the video back. What we're supposed to be doing here is looking at our different rules. Product rule says that if you take the logarithm of a product, what we're able to do is actually split it up into a sum of those products or of those factors. So log base b of r plus log base b of s, right? If there's a quotient rule, that's when you have a division problem, right? So log base b of r divided by s, we can rewrite that as log base b of r minus, so we can have a difference, log base b of s. And then the power rule is the most interesting in my opinion, but when you have a power, then what happens is you take that power and it just gets multiplied by the log instead. And what we're going to do for example one is I'm going to show you how we can prove that these things happen. You can do this type of proof with all three, but we're going to focus just on proving the first one, that product rule, and then you can try the others on your own if you really want to, but it should work out the same type of way. Something that's really important for us to understand before we go through this is make sure that you are aware of your different exponent rules from Algebra 1. So if you need to review those or pull up a list of those just to have that as a reference, feel free to do that because you do need to be familiar with those as we go through this a little bit, okay? All right. So example 1 is just asking us to prove the product rule. They said prove that if you have log base b of r times s, that it really is the same thing as log base b of r plus log base b of s. Now, for those of y'all who haven't seen a proof since geometry, I'm just going to start off by saying this proof is not the exact same as the types of proofs you did in geometry. So we're not going to do the 2-column thing with the statements and the reasons and do that. What we're going to do is just basically algebra to show that this is the case. And so it's what I would call a algebraic proof. And, and you can justify all the steps with different algebraic properties, but, it really is just more algebra than it is what you would have thought of as like a geometry proof. So it's not the same. Okay. I am going to do one thing here at the beginning just to kind of set the stage for this a little bit, make it a little easier to work with. Because I'd rather not have to write log base b of r a bunch of times or write log base b of s a bunch of times. So I'm going to try to make this a little simpler on myself. And what I'm going to do is I'm going to let log base b of r, I'm just going to say let that be x instead. That way, every time I want to write it, I'm just writing an x and not this whole big fat thing, okay? And I'm going to do something similar with the other one. I'm going to say let log base b of s, I'm going to let that be y for the moment because it's just going to make it a whole lot easier to write an x or a y rather than writing this whole big thing every single time I want it, okay? This also lets me make another statement, okay? If this is the case, then we would be able to actually rewrite these as exponential equations instead of logarithmic. So you just got to remember the way that you convert between logs and exponents. Remember, the base of your log is the base of the exponential, right? We would put this as b to the x power equals r, okay? Also, for the other one, we get a similar idea. We would say b to the y equals s. And what that does is it allows us to talk about things in a little bit more simple terms. So remember how we're supposed to prove log base b of r times s is equal to this, right? This sum. I'm going to start with log base b of r times s. And what I'm going to first start off with is I'm going to substitute. I'm going to replace the r and the s with what we know they're equal to. You remember how back here we showed that r was the same thing as b to the x power? So I can replace that with a b to the x power. Same thing here. Remember, this was r times s. Well, I can replace s with what we knew it was equal to as well, b to the y. That's just using a substitution property. And then from there, we can use our exponent rules. Remember how I said you're going to need those? When you multiply these exponents and they have the same base, b to the x, b to the y, right? When that's the case, you have to add those exponents. Okay, but remember what we talked about in our last lesson with the logarithms? When these things match, log base b of b, they basically just cancel each other out, and you're left with that exponent as just x plus y. All right, guys, believe it or not, we're almost done. Remember how we used the x and the y to just kind of keep things simple? I didn't want to have to write log base b of r, log base b of s over and over. Well, now I'm going to put those back in place because that is truly what x and y were. So I'm going to go back and say, okay, well, x was log base b of r, and y was log base b of s. And we have just proven that that product can be written as that sum. We are done with our proof. And put a little symbol just to say, I'm done. All right. That's it. So a little bit less painful, I think, than the ones that you would have done in geometry because it's just more algebra based. All right, next thing, we've got an example here where we are going to expand. We're going to use these properties to write these things out as a sum or a difference of different logarithms. Okay, so that way, in some cases, that can allow you to simplify things out some. So we're going to look at this and start off, like I said, just expanding them, and then we'll show a different type of problem in a moment. Okay, but it says expand using properties. Well, I've got log of 8 times x times y to the 4th. That's what we're starting off with here. Let's zoom this in just a hair. All right, so if we're working with log of 8 times x times y to the 4th, what I'm going to be using to work through this is the product property. To start off with, that product property allows me to rewrite this as a sum of logarithms. We just showed how that works, but it allows you to do basically a shortcut. And I can rewrite this as log of 8 plus log of x plus log of y to the 4th. Okay? Well, this is not the only way to rewrite this. We can still even expand it out some more. And I know this sounds a little bit wild, but I want you to think about the number 8. And we're going to talk about how you can write 8 as a number to a power. 8 could be written as 2 to the 3rd power. Okay. Well, bear with that for a moment. Remember that power rule that we had up here? And I said that was kind of the weirdest one. When you have a power, you can end up rewriting it as that number times that logarithm. It doesn't have to be written as a power anymore. Well, that's what I'm going to do here. To expand this out fully, we need to write this as 3 times the log of 2. That exponent gets multiplied. Plus log of x plus, and then over here, 4 log of y. That is it, fully expanded. That would be your answer. Which I know sounds a little bit wild. We kind of did the opposite of simplifying, but that's what expanding really does. All right, we're going to do another one here. I'll do it in a different color just to kind of help differentiate them. We'll do red, make it kind of look Christmassy, right? All right, so here we go. We got the natural log, and this time we're seeing a quotient. I see the natural log of the square root that's divided by x. So the first thing I'm going to do is I'm going to use that quotient rule to write this as a difference instead. So I'm going to have the natural log, and then we put inside there x squared plus 5. we're going to subtract the natural log of x. Okay? Well, from there, you might be thinking, I have no clue what else to do. You might want to do something with this squared that's on the x or something, but I can't really. Here's what I need you to recognize. A square root can be written as a power instead of as a radical. We've talked about this several times, but when you have the square root, it is the same thing as a 1/2 power, which would allow us to use our power rule. Remember we said if you have a power, you can write it out in front. So really this is 1/2 the natural log x squared plus 5 minus the natural log of x. And at this point, it really cannot simplify anymore. I have the natural log of a sum, but I don't have a sum rule, right? You might be thinking, well, it's the product rule. There's where the plus is. But I want you to look at this. The product rule says logarithm plus a logarithm, right? That's not what's happening here. This is the logarithm of a sum, and that does not have a property. This does not simplify any more than what you're seeing. Therefore, you're done. Okay? All right. Last one we're going to do is a condensing problem for this video, and then I will cut it off and we'll make a part 2 for the rest of it. Okay? So example 3, you're seeing here, they said condense using properties, write as a single log. So instead of writing it out as multiple logs that are added or subtracted, we're going to write it out as a one singular log. All right, so you won't see those separate terms like that. You're going to see it written only as one natural log in the whole thing at the end. Okay, so this says natural log of x to the 5th minus 2 times the natural log of xy. All right, so remember we are supposed to be condensing this, trying to write it as one log rather than keeping it separate as 2. And the sometimes the challenge is knowing what property to do first. A lot of times people will look at this and say, I know exactly what to do. We need to do the quotient rule and we need to do the power rule. And you would be right. Those are the 2 that we need to do because I see subtraction and there's a number that's multiplied in front of this log. However, the order matters. So which one do we do first? That's the question. I want you to look back up here. And when I see that quotient rule, I want you to look at these logarithms. Do you see how there is no number written in front of those logarithms? We just see log base b of r minus log base b of s. There is no number written in front. That indicates that when you do that quotient rule, there should not be numbers in the front, right? So I think I'm going to need to take care of that first. Let's use the power rule and rewrite it so that this term does not have the 2 in the front. It would really be the natural log of x to the 5th minus the natural log of xy, that product, squared. Okay? And so what we really should be having here is, remember, this is xy all squared. It's not just the y that's squared. It's both x and y. And at this point, I can condense it all the way to a quotient, make it x to the 5th over xy raised to the 2nd power. Now that also can simplify. This is the natural log. We've got x to the 5th over x squared, y squared. All right, one more step, do a little bit more simplifying. This is the natural log. And then we're going to have, this is x to the 5th over x squared. We got a little bit of canceling that'll happen here. We get x cubed over y squared. That is it, simplified all the way down. Condensed form, one logarithm, simplified as possible. Okay? All right, guys, that is it for this video. In the next video, you are going to see us talk about change of base. So definitely stay for that one if you missed that lesson, or if you just need to review it. That's where that part will be, as part B. Okay? And I will see you on the next one. Bye.